Welcome to the fourth of this AIS developer video series. Our subject today is how to run secretly in the background. We will be referring to app 203, the secret agent. As always, you can see the code documentation from index.html, which is in the root of the Git check-in. Here it is, index.html. We've opened it here, and now we're going to look at 203, the secret agent. One of the most important classes here is the receiver of system events. It's a simple class, and all it does is on-receive for various events in the operating system. Let's go to the code and specifically the manifest to look at them in more detail. This is the Android manifest. It's a meta file, so it's not written in Java, C++ or anything else, which describes aspects of the application itself. Any GUI application for Android will have this activity section up here. You can see this is for a GUI. We don't use the GUI very much in the secret agent because almost everything that it does in secret. And it can't be seen. If you're holding the device, you probably won't even know it's happening. But as I say, most Android apps have this. That's the class that's fired up for the GUI, and that's about it. It's launched from the main screen, from the launcher. But now you will notice that this app also has a receiver, which is far more interesting. The receiver fires up that system event receiver class that we just talked about, and it listens on all kinds of different flags, such as boot completed, which is if the device has just been powered on from a completely powered off state, so not started but completely powered off and then powered on again. And that's the first. These are the first messages that we get: boot completed, quick boot power on, and some HTC devices have a different quick boot power on. We receive all of them, so we work on any device. That lets us start when the machine starts, so you don't have to have run Secret Agent app in order to receive notifications. You'll also see some other ones that we respond to, such as screen on. If the user is present, shut down, so that we're able to report the fact that the device is being switched off. This is a hard power off, not just screen. We also receive information about incoming and outgoing phone calls and texts. So that's how we're able to spy on the different things that are happening in the operating system, the ones that we're interested in. All of these events are sent to our system event receiver. Now this is a class, you'll notice it has nothing to do with the GUI. It doesn't start a GUI, it just starts this class in a separate thread all by itself. Let's have a look at it. We just go to the Java com Scarlet line and we can see system event receiver class. There it is. It's very simple. It's a broadcast receiver, and on receive it deals with the different messages in different ways, but the bottom line is that it's making sure that it squirrels away all of the data that we want for later on, such as the phone number from which the phone call is coming or a text is going to. If it's a location, then the position. So we make sure we get all that data, we package it up, and we send it to our service. our service runs continually in background. Now, obviously it's got to be started, so the event does not assume that the service is running. This means that if we receive any message, such as the boot completed, it'll start our service even if it's not running. The service will then continue to run in the background so that it can do periodic updates and all of this sort of stuff. So normally it's running all the time. If you've turned the machine off, obviously it's not running, but when you turn the machine on, one of the earliest triggers will start it again. So let's now look at that service. Here it is, the listening service, and it gets a start service call. Here we are. This is the on-start command, which is called by the operating system when we request the service be started. And in here, it makes sure that it's registered. So even if it'll re-register all the books. So even if it's been completely switched off, this will start up things like location reporting, regular selfie taking, and all of that sort of stuff. We then deal with the event, whatever it happened to be, in order to report on it. And all of these functions then go later to post, where it puts in a queue a post for the WordPress server that we're using to show the data. If I bring that up now, I'm using the Gifted Cloud one at the moment. So here we can see, here we can see a recent start event. This is the data that's reported. So this is when the agent was started. It did a screenshot. We're simply running secret agent, as you can see right now on the device. This is the device that's reported. You can see our location, and there's me on the snapshot, and this is taken completely in secret. The user won't normally know that that's happening. And here's an update. For testing purposes, you probably want to be able to switch between the different servers. I'm using Gifted Cloud at the moment. You can do that very easily now from the settings menu. I'm clicking on settings, and if you look down the bottom, you can see 3 items. Set server credentials to AIS, that's the default, that's using AIS servers. But there's also set credentials to Gifted Cloud, which is the one I'm using right now. As you can see, it's the AIS testing Gifted Cloud WordPress server. And then the third one is an internal development one. You probably won't reach it from where you are. You can also set it manually if you had a different WordPress server set up, as you can see above, but this will set the API, the username and the password. Now, there are several tricks that you need to know to be able to do this secret reporting. For example, here, this photo taken. The Android operating system, from quite early on, doesn't allow you to take a photo without first showing a preview window, which alerts the user to the fact that a photo is being taken. So what we do is we create a preview window which is invisible, and then use that to take the photo. So the GUI thinks it's displaying the preview, but in fact it isn't. On earlier versions of Android, you were able to install an app which can hook those hooks that we were talking about in the manifest, such as boot completed, without ever having run. But in more recent versions, I believe it's 5.0 and above, an app has to have been run at least once before it's allowed to hook these. But after that, it can carry on forever. So it can hook, for example, power on, and then that means it can restart itself if the device was ever switched off, and otherwise can continue to run. So yes, earlier versions of Android you didn't need to run at all. Later ones, the GUI does have to have been run once, but after that then the secret agent can report as often as it likes. Apart from that, this is a standard service app, so the service code will be familiar to people who've written different types of service. And what our service does is it packages up information and posts it to the WordPress API, as you can see here. So that's an introduction to running secretly in the background. So there are a couple more items that we need to mention. On start command is the standard call that the service receives, and we want to return start sticky, which means it keeps the service around. Here is the return value. And that's about it. So thank you for listening, and I will see you soon.